So today we're going to be talking about cloud native development and Openshift application runtimes. Now, this is already a pretty wordy and verbose title. It's really going to be about Openshift application runtimes and Openshift as well. So I'll be covering both topics today, not just focusing super narrowly on the runtimes aspect of it, but we'll also talk about Openshift as well. So before I get into the cloud native, let's talk a little bit about where we're coming from in terms of past history and background and experiences. Most of the applications that we're developing have been developed in the past have traditionally been done with using a monolithic architecture, right? Monolithic architecture, most people are pretty familiar with it. It's where you've got all the components of the application, the user interface, the services, the data access layer, et cetera, all in one single deployable unit that gets deployed and managed as a single entity, right? And typically you would take your monolithic application and you would often deploy it on top of an application server, like a JBoss EAP, a WebLogic, or WebSphere in .NET World IIS, et cetera, right? And that worked great in the time, but now we're moving to a new paradigm, right? We're getting to a point now where clouds are providing us with elasticity and agility. And we're finding those old traditional monolithic architectures are not necessarily being able to move into this new paradigm, this new environment way of doing things, right? We want to be able to leverage this new way of doing things in order to get the elasticity and the agility that our businesses are looking for in order to compete effectively in the marketplace. Now, when I talk about cloud native development, the cloud is kind of a big buzzword nowadays. This is not necessarily meaning, AWS, Azure, et cetera, public cloud providers. Cloud is really more about the mindset of developing your application and leveraging, like I said, that elasticity, that agility that you get from a cloud. But it's not really tied to a particular set of infrastructure or way that your application runs in that infrastructure. So why build cloud native applications? I kind of feel like I should have put this slide at the end as kind of that why this is so awesome. But we'll do it up front here. And really, the biggest reason why to do it from my perspective is the faster service delivery, right? We've all been trained with our phones nowadays to expect constant application updates, and our users are being trained the same way. And within our enterprises, we're finding that users are having those same expectations for those applications. Both external consumers outside of your organizations that are using your applications, but the internal audiences, the internal consumers as well. The old days of saying, you know what, we need a feature and I can deliver that to you in 6 months' time or 12 months' time, that's slowly going away, right? People are trained, they want this stuff to happen now and happen faster. Cloud native development allows you to deliver those features quicker and faster than ever before. An interesting correlation when you get into faster service delivery is that it actually increases your service quality and it reduces your risk. And for a lot of people, when they first hear that or think about it, it seems pretty counterintuitive, right? Wait. Instead of delivering every 6 months, I'm delivering, say, every week. And you're telling me that my quality is actually going to go up, but I'm doing this more often. Because they think of how they did deployments in the past as being this large, laborious, manual process, right? Where you're up from, say, 9 p.m. till 8 a.m. the next day doing a deployment, things are always going wrong, et cetera. When you're doing the cloud native development, there's more automation, more things in play, and we'll talk about that. But the biggest thing from my perspective really is that you're reducing your batch size. Batch size is really referring to the amount of work that you've encapsulated in what you're pushing out in terms of your production, your deployable unit. When I push out a deployment after 6 months of effort, I've got a lot of features, a lot of bug fixes that are represented in that 6 months of effort, a lot of complexity, right? My batch size is huge. When I'm pushing out a change that happens every week, my batch size is pretty small. What's changed in that application over that week is a very well understood item. From that perspective, that's why your quality goes up and your risk goes down. Batch size has been known for a long time to have a direct correlation and impact on quality. And that comes from the manufacturing industry from the early 80s. Toyota looking at the lean methodology and that kind of stuff. Found that out a long time ago, and it applies equally to software development. So when we start talking about new architecture paradigms, we had the monolithic architecture. People are now looking at microservices architecture, right? Taking that monolithic application and decomposing it down into individual services. Those services have discrete boundaries, and they're deployed, operated, and managed as independent units, right? People go to microservices for agility. That is the primary reason why an organization should be adopting microservices. If you're thinking about going to microservices because it's the latest buzzword, the newest hype thing, I would suggest revisiting it. But if you're looking to increase your agility, being able to compartmentalize the work effort and break it down into separate teams, being able to manage these independently, is where the microservice benefit comes in. But it's also important to understand that cloud-native applications are not just about your architecture, right? While microservices are often thought of as synonymous with cloud-native applications, it's not necessarily true. You can do cloud-native style development with an existing monolithic type application, applying all those same practices and principles that we'll start reviewing in subsequent slides to your existing monolithic applications and gaining some of those benefits in terms of the faster service delivery, the increased quality, and the reduced risk. So what is a cloud-native application in terms of its characteristics? If you were to go out there and look at all the different vendors that have portfolios of products in the cloud-native space, you'd see a lot of different things that they identify in terms of things that they think are important to cloud-native development. But you're going to see certain common characteristics repeated over and over again. And when I've looked around the different vendors, these ones here are the ones that I tend to see come up more often than not. The first point is really having a service-based architecture. And the idea behind that is to decompose your applications, similar to what we talked about in the microservices, into well-defined services with well-defined boundaries in terms of the functionality they provide to the business. Interfacing between those different services are done with APIs, right? Those APIs are what allow you to manage the interaction between the different services and manage the life cycle of that interaction over time. Now, when you start going to faster service delivery, you can do that faster service delivery using your traditional methodology. What you're going to find is it's very difficult to keep that up, right? All the automation, all the deployment steps that you typically need to do for a normal application, it's a lot. Like I remember the old days when I have my EAR file, I would throw it over the fence to the operations team with my 10 pages of instructions and all the things they'd have to deploy, because it's not just the EAR, there's configuration settings that need to be updated, there's library files that need to be updated, et cetera, right? It's a fairly intensive process doing that kind of deployment. Containers help you a lot with that by encapsulating everything your application needs into the container itself, and that container can then be portable across different environments. So I can be confident when I run that container in the development environment, it's going to run the same way in my test environment. And finally, DevOps. So I think in the keynote this morning, Mike Carty spoke a bit about culture. If you're having trouble with your monolithic applications in terms of your development processes, just switching to microservices is not going to fix your problem, right? It's not all of a sudden going to be rainbows and unicorns and everything's great because now I'm running a microservice architecture. You really need to look at your overall process and how you're building your applications, and we'll talk about this more in subsequent slides. So as we've gone around as Red Hat to different customers, we tended to see the journey to a microservice or a cloud-native type architecture following this path. And I'm going to break this down into its components as we go through the slides. But one thing I wanted to point out was this thing only here, and only then. The idea is that in order to be successful with microservices, your organization needs to have a certain maturity in order to reach that point. If you ever go on a roller coaster ride with your kids, they always have that sign, you know, you must be this tall to get on the roller coaster. Martin Fowler has a nice blog, it's the equivalent of that, which says you must be this tall to use microservices, right? You have to have a certain level of maturity in an organization in order to be able to deliver microservices effectively. And that's simply because where I used to be delivering one application with 100 services in it, now I'm deploying and delivering 100 different things in my infrastructure. If you do not have that maturity in your organization, you are not going to be successful in managing that. So let's walk through these in more detail. Oh, sorry, I forgot one thing here. So remember I talked about the architecture. So microservices is one way to go, but you can do cloud-native development with what we call a fast monolith type architecture, which is I got my traditional monolithic application, and I want to use my cloud-native principles and practices in order to accelerate the development of that monolith. We have a customer called KeyBank that did exactly this. If you go visit that link at the bottom, and the slides will be available online after this presentation as well, so you don't have to necessarily write down those links now. They went through this process very successfully, right? They refactored their application to take advantage of new technologies. They adopted containers on Red Hat Openshift in order to facilitate and accelerate their deployment methodology. They incorporated automated testing. I'm a huge believer in automated testing for applications in terms of ensuring the delivery of the application. They implemented continuous deployment pipelines as well as with other things. And they dropped their release cycle from 3 months to 1 week, right? Which was huge for them in terms of their overall competitiveness in the industry. Everybody's being disrupted these days. Financial industries are no different. There's a bunch of different fintechs out there now that are pushing our traditional banks hard, and KeyBank needed to adapt, and this is what they did in terms of being able to deliver the application and features that their customers were looking for quicker than ever before. So let's look at the path to cloud-native applications. Do a quick time check. So the first part really is reorganizing to DevOps. When I do my OpenShift presentation, I often talk about DevOps because OpenShift is works well in a DevOps methodology. And DevOps, if you're not familiar with it, is really built on three pillars. There are process, people, and technology. And I always joke, I'm here to talk about OpenShift, which is technology, and unfortunately, that's the easiest part, right? Dealing with technology is relatively easy, and it tends to be one of the mistakes people make when they start going down the cloud-native path, is they focus on the technology, and they don't focus enough on the people and process and the culture in the organization. I think Mike Carty this morning talked about that as well. The quote here is from Joe Beda, who's the CTO of Heptio. Cloud native is structuring teams, culture, and technology to utilize automation and architectures to manage complexity and unlock velocity, right? Essentially being able to deliver your applications faster than ever before by adopting the cloud native principles and practices. How many people here are using DevOps right now in their organizations? A few hands? Okay. How many are still using Waterfall? Yeah, a few hands, okay. That's pretty typical for most organizations, what I see when I ask it. All right, so the next 4 blocks are really about how do I deliver my application faster and more efficiently? How do I get that maturity that I need in order to be able to do that successfully? And there's 4 different components to this. The first component is really offering self-service, allowing your developers, your operations team, to be able to provision infrastructure on demand as needed. Right? So if I have my developer, for example, he's building a new feature in a new branch in source code, he needs a new VM in order to power up a new environment to support that. I don't necessarily want him filling out a ticket and having to wait 4 weeks for that VM to be provisioned, right? You should be able to go to a portal, fill out something and self-service, and have that VM almost instantaneously if he needs it. Automation is about eliminating all of the manual steps that we often traditionally do in a deployment process, right? You want to be able to automate your deployment process from end to end in order to be able to deliver your application effectively. Now, when you do automation, organizations start with it, it's very tempting to insert manual checkpoints as you do that automation, right? It's mostly like peace of mind. For a lot of organizations, it's hard to let go, right? And it's pretty natural. But the more you can resist that temptation and the more you can automate, the faster you can accelerate your delivery and deployment. From a continuous delivery point of view, that is simply moving your application through all of this life cycle in terms of the different environments that it needs to flow through in order to deliver that application. So as a developer, when I check in my code, I want that check-in to automatically trigger a build of my code and be tested with everybody else's code from an integration point of view so that I know right away if that code fails. As a developer, myself, there's a certain stack that I maintain in my head, right? I know the algorithms I'm working on. I know the variables I'm working on. The sooner I know that I have a problem in my code, the easier it is for me to fix it because I still have that stack in my head. I have that context. I know where I am, right? If I don't find out about that bug until we do full-blown regression QA testing 3 months later, coming back and fixing that bug becomes much harder. Adopting continuous delivery along with the automated testing that goes with it allows developers to find those issues quicker and faster than ever before. And it gives you the confidence that the application that you're actually deploying at the end of the day is robust, reliable, and consistent, and most importantly, the process is repeatable. And then finally, advanced deployment techniques. So on that KeyBank slide, one of the things that they did was they were able to deploy without taking any downtime, right? So that's huge. How many people here do deployments, for example, from 9 p.m. to 8 a.m. the next day? I know I was one of them, right? I did a lot of them, and they're not fun. Nobody enjoys doing that, right? Really what we want to do is move to doing deployments during normal work hours and leveraging these advanced deployment techniques like Blue, Green, AB, Canary in order to be able to deploy our applications, new versions of our applications, during those work hours without taking an impact or downtime to the business. All make sense so far? By the way, if you have any questions, feel free to interrupt at any point. So when you start down that path of deploying your application, you want to be faster, more agile with it. Containers are very naturally synergistic with that, have a natural synergy with that process, right? If you've never, how many people here use containers? Oh, quite a few. Okay, so you're going to be familiar with this part already, but feel free to correct me if I get anything wrong. So what a container is really sometimes dependent on who you ask. From an operations point of view, It's about isolating Linux processes using features in the Linux kernel like C groups and namespaces, right? So you get you get the same sort of isolation that you do with a virtual machine, but you're sharing the same kernel under the hood. From an application developer perspective, which is where I come from and which gets me really excited, is it allows me, like I said earlier, to package my entire application up in a way that allows that application to be deployed quickly and easily, and then portable so I can move that application from dev to test to QA. I was somewhat infamous in the Java EE days of when I was a consultant of complaining to customers that if they're rebuilding their ear in their dev environment, in their test environment, in their prod environment, that they're doing it wrong, right? Because they need to move that same ear from environment to environment. And that's what containers are all about. They're providing immutable infrastructure for your application and allows you to move it quickly and easily from environment to environment. The nice thing with containers is because they're sharing the same Linux kernel, they're not an entire operating system like a virtual machine is that you achieve much higher density in infrastructure than you typically do with a virtual machine environment, right? So in a virtual machine environment, I've got my app, I've got my VM, and that's taking a certain amount of space in my infrastructure. With a container, on the other hand, because I can have multiple containers running on the same VM, sharing the same kernel, I can achieve much greater density that way than I can with virtual machines. So when customers start off with containers, they deploy 5 containers, they deploy 10 containers. It's all going great, everything's swimmingly, and they're getting a lot of the benefits out of the containers that they would expect to see. But they're quickly realizing, I'm still doing a lot of the same stuff that I used to have to do for deployments, right? I'm still having to set up VMs. I'm still having to handle networking in terms of providing DNS for my applications, in terms of setting up load balancers and farms in order to load balance my applications. I still need to provide persistent storage and manage it on behalf of all these applications, right? Wouldn't it be great if there was a way that I could just throw my containers at something and say, you know what, you take care of that deployment, you take care of all of that stuff. And that's where a container platform like Openshift comes into play, right? Openshift is about managing a set of resources that you provided on behalf of the application. So you give Openshift a set of compute, a set of network, a set of storage resources. You tell it that I want this application to be deployed, and you tell it what the characteristics of that application are, and Openshift will automatically take care of scheduling and deploying that application on the infrastructure. As an operator, I no longer have to be concerned about, I'm deploying application A on VM B. Openshift is managing all that for me. And that really accelerates the process of deploying your applications and helps you get to that cloud-native development that organizations are looking for. Now, Openshift itself is based on a Google project called Kubernetes. People here heard of Kubernetes? Yeah? Okay. So Google's been doing containers at scale since about 2006. They had an internal project at Google called Borg. If you're a Star Trek fan, we are the Borg, we will assimilate you. And Google wanted to bring all the lessons that they learned with the Borg project to other enterprises, organizations, and they started the Kubernetes project in order to do so. Openshift leverages Kubernetes as its orchestration engine, and we provide a lot of additional features on top of that. So when you deploy your application into this type of environment, there's a number of services that your application is going to require that Openshift provides, right? One of the biggest ones is simply service discovery. I talked about how Openshift is managing all of your infrastructure for you. Sorry, just one second. That's better. Openshift is managing all of your infrastructure for you. So when I deploy an application, that application could be running on a VM over here that Openshift is managing, or a VM over here, who knows, right? Its IP address is constantly changing. So if I've got microservice A that wants to talk to microservice B, how do they find each other, right? Openshift provides that for you through service discovery, making it easy for those applications to communicate to each other transparently, regardless of where they sit in the actual infrastructure. There's lots of other things that Openshift provides in terms of managing your logs, providing operators the information they need in order to manage and monitor those applications. And then there's a whole development layer on top of it that we'll see in the demo that I'm going to do around CI/CD and deploying your application. Now, the interesting thing from my perspective is that when you get into the container platforms, we're starting to see an evolution in terms of how microservices are actually built and delivered, right? If you go back to 2012, most people were building their microservices around the Netflix OSS stack. If you're not familiar with the Netflix OSS stack, Netflix has obviously been doing microservices for a long time. a lot of experience with it, and they've encountered a lot of the common problems people typically have with microservices around intelligent routing, service discovery, circuit breaking, et cetera. And they provided a set of applications and libraries in order to do that. Now, the interesting part is when you look at this slide up here, you can see in the old days, my microservice, while it had business logic, it also had a lot of infrastructure components built into it, right? The microservice itself could be responsible for the load balancing using something like Netflix's ribbon in order to do that load balancing intelligently. And what we're seeing is this functionality now is coming out of the actual microservice and moving into the platform itself, into the infrastructure, right? So the developers can now concentrate just on building the business logic of their microservice and not necessarily have to worry about all of the infrastructure aspects, right? Take that away. The other benefit of that is it makes it agnostic in terms of technology stacks. So the Netflix OSS stack is very tightly coupled to the Java platform. If I want to write a Python application, a .NET application, I need to find an equivalent stack in order for those applications to function with it in many cases. When the platform is doing it, all the technology can run seamlessly on top of that platform and leverage the benefits the platform is providing it. Now, one of the cool things that's coming down the pipe in Openshift is a project called Istio. I don't know, anybody's familiar with Istio? Heard of it? A few? Yeah? Cool. So what is Istio? Istio is a service mesh for applications. The idea behind Istio is that when you deploy your microservice, all those features that the old Netflix OSS stack, the Zool, the Ribbon, the Historics that would provide for you, Istio is now going to be providing that for you out of the platform. And the way it works is pretty darn cool. So the way it works is that you've got a control plane that's operating in OpenShift. And then when you deploy your application, your pods, what Istio actually does is it injects a new container into that to manage all of the network traffic, and that's called the Envoy proxy. It provides all those features that the Netflix OSS stack would provide previously, but independently of your application. So you get the intelligent routing, you get the load balancing, you get the service resilience, the telemetry and reporting, and the policy enforcement, all out of the platform rather than having to manage that within your application itself. I actually had a slide before this I had to take out for space that said, the future, it's glorious. I'm really looking forward to Istio because it offloads so many of the responsibilities from the application and makes development so much easier for both developers and operators in a DevOps methodology. And then finally, if you do all of those steps and you're ready to go, you're ready to adopt the microservices fast monolith paradigm, all right? But it's also, like I said, very important to not just skip ahead and start microservices right away without looking at all of the different things that you need in order to successfully deliver it. Pretty much any organization out there can deliver 5 microservices without too much effort, right? Whether you're using all these steps or not. From that perspective, it's just 5 new applications. But like I said, you take that monolith of 100 services and you break that apart into 100 deployable units, that's where things start to break apart in most organizations. And if you don't have that maturity, that culture in place to handle that, then you're going to struggle when you try to do the end step. Make sense? Any questions? Comments? Okay. I worked hard on this slide. So Red Hat OpenShift application runtime. So Red Hat OpenShift application runtimes is called ROAR internally, right? I was joking with my wife, maybe I should go ROAR really loud, but then she said, you probably give somebody a heart attack. The paramedics would come, it would just be very disruptive. She's the smart one in the family. So what is ROAR? ROAR is really a set of opinionated runtimes that Red Hat provides on top of the OpenShift platform. So when developers start up with OpenShift, we have a large catalog of technologies, tools that developers can use. And what we really wanted to do is to kind of bundle what we thought are kind of the best suited technologies for building microservices in today's technology stack. So there's a variety of different runtimes that are available, and I'll walk through each one in turn from left to right. So Eclipse Vertex is a Java framework that closely mirrors Node.js. So if you're familiar with Node.js, or not familiar with it, I'll explain it. Essentially in Node.js, it's a reactive asynchronous style programming environment. So if you're coming from a traditional Java programming background, which I certainly am, You're used to, running in a multi-threaded application server. Every thread is doing its own work. When that thread needs to call out to a database, it blocks, right? So if it's supposed to be responding to a user, that thread is essentially blocked until we're finished with that database call. Then we prepare the response and we send it back to the user. The way Node.js works is that when it comes in, it needs to call a database. It does that asynchronously, and the thread continues processing. When the database processing is finished, it gets an event back into the main thread, which then can do the work that it needs to do before providing a response back to the user. The benefit of that approach, really, over a traditional programming paradigm is that you're making much more use of the thread, the CPU capabilities of the application, because you're never having to wait for I/O. So whenever I'm looking at an application from a performance point of view, 9 times out of 10, my performance problems are not the application itself, it's the back end, right? Calling other applications, web services, calling out to the database. All of those things take time. And you think about it, you take all those chunks where threads are just stopped, waiting for a database or for I/O to happen, how much more performant your solution is. So Vertex is taking the same approach as Node.js in terms of providing a reactive asynchronous programming model, by using the Java language and frameworks to do it, right? So if you're an existing Java programmer, you don't want to necessarily learn JavaScript, Vertex makes it easy to adopt that programming paradigm. Wildfly Swarm is actually in the process of being renamed or rebranded to Thorntail. The reason why it's being renamed is there's a lot of confusion in terms of the Swarm name with other products that are out there. If you are an existing Java Enterprise Edition programmer, then Wildfly Swarm is very interesting to you. So when I say JEE, people tend to have a very bad image of it because they think back to the old days of J2EE, where when I wrote an EJB, for example, I had to write 4 frickin' files in order to build my EJB, right? I had a home interface, a remote interface, a descriptor, blah, blah, blah. It was painful. But JEE hasn't stood still. From a programming point of view, it's very comparable in terms of its simplicity and its efficiency to Spring nowadays, right? So if you have developers that are already doing Java Enterprise Edition development, but they want to jump into the microservice world, what do, right? Wildfly Swarm is essentially providing the same capabilities as something like Spring Boot, but using the JEE APIs. You can create a fat jar, you can quickly start up your service, no problem at all, and you can pick exactly which components of JEE you want to run in your application. So it can be pretty lightweight and compared to a full-blown application server. Node.js I've talked about already. Spring Boot, everybody familiar with Spring Boot already? Okay, so if you're not, probably most people are familiar with the Spring Framework. So Spring Framework started in the early 2000s by a guy named Rod Johnson. And really, the idea of the Spring Framework is it was an answer to what he perceived, rightly so at the time, the bloatness that was associated with Java Enterprise Edition, right? He wanted to build a framework that was built around dependency injection and allowed developers to be much more efficient in terms of how they built code. That framework has continued to evolve over time, and Spring Boot is essentially allowing you to take Spring Framework-based applications and run it without an application server. So when I run my Spring Boot application, I'm essentially running what's called a fat jar. It's called a fat jar because every dependency your application needs is packed into that one jar, and it's a pretty big jar. But you can simply go, Java jar run, that jar, and off you go, your application's up and running, no application server needed, right? In reality, the application server is kind of embedded in the fat jar, but from a packaging point of view, it's very convenient and straightforward to get your application up and running. And then finally, we have JBoss EAP. Now, JBoss EAP, while it is a Java Enterprise Edition server, it is extremely well positioned in terms of doing cloud-native development. JBoss EAP in the Openshift environment can scale elastically with the Openshift environment. So if I think of a traditional traditional application server, I would typically have a descriptor that defined all of the servers or the VMs that I'd be sitting on, right? I'd have my IP addresses for them all. They would know where to talk to each other in order to form a cluster, et cetera. That worked great in traditional infrastructure. It doesn't work great when you want to scale elastically because you've got to go in and update that configuration all the time. Many application servers don't react well to being able to do that, right? Or there's downtime associated with being able to update it. The great thing with JBoss EAP running in the Openshift environment is it can auto-discover all of the JBoss EAP members that are running and form that cluster automatically. If you just want to expand your cluster of EAP, you can simply scale it up in Openshift just like you do any other application. So that means when I was talking about that fast monolith, if you have an existing JE fast monolith application, you want to bring it in the cloud native world to take advantage of the capabilities of Openshift, you can use JBoss EAP and ROAR in order to provide those capabilities, right? And we've done lots of lift and shift type deployments of JE applications in Openshift and JBoss EAP that I'm very confident saying that anybody who tries that would be very successful. All right, so why ROAR? So I talked about JBoss EAP. It allows you to run your existing Java Enterprise Edition applications. Similarly, if you have existing Spring Boot applications, Node.js applications, you can bring them over to Openshift and run them quickly and easily on the ROAR platform. Another interesting thing with the microservices architecture is that it allows people to pick and choose the technologies that best meet the needs of that particular service, right? So if I'm running writing a front-end web service, maybe I want to choose a Node.js framework using like React or Angular running on that platform, right, as my tool of choice. If I'm writing an integration where I need, the depth that the Java ecosystem brings, maybe I want to do that in Spring Boot or Wildfly Swarm. The great thing is with ROAR is that you have a choice in terms of the different tech tools and technologies that you can provide, but all supported and certified by Red Hat. And finally, all of these runtimes are integrated with Openshift and leverage the capabilities in the Openshift platform. All right, so the getting started experience with ROAR. The hardest thing for any developer when they're adopting a new technology is where do I start, right? I know whenever I start a new hobby project or a new development, I'm always kind of sitting at my desk going, the first part of writing that first line of code is always the toughest part. Once you get going, it goes pretty quick after that, right? The nice thing with ROAR, and we'll see this in the demo, is it provides a launcher that allows you to quickly build a skeleton application that you can expand and build on and see best practices from a Red Hat perspective in terms of how to integrate within Openshift, as well as build various styles of applications that are needed. And we're going to walk through this process in the demo, so I won't labor it too much in this slide. All right, so I've gotten you all excited, maybe, I don't know, we'll see. But we'll see after the demo, because the demo is always exciting. Either it works and it's exciting, or it doesn't work and it's exciting. But either way, it's exciting. So if you want to get started, you can find all of these free books at developers.redhat.com. No cost. You can download them as PDF files, read them. You can get up to speed in terms of the latest and greatest. One book I'm going to kind of recommend in particular, because I'm not a database guy. I'm a developer. I use databases. Sure, I'm comfortable, defining my database scheme in that, but I'm not a hardcore DBA. I found this book really interesting. So when I started with microservices, one of the tenets of microservices is that every microservice owns its own data. And I had a lot of questions about that. Okay, that sounds great in theory, but how does that work in practice? Where are my foreign key constraints? How do I do reporting across all these different databases? How do I manage compatibility of the database as the microservice now is being updated more and more often, right, compared to a monolithic architecture? And that book does a great job of kind of taking you through all those questions that people typically have when they hear that about the microservice world and answering those questions. All right, so let's get to the demo. Go into the launcher, what it's going to do is it's going to walk you through a set of questions in order to define what we call a mission. A mission is really what kind of application you're trying to build, and then based on that mission, we will give you the code that is needed to build that application as a starting point. So my first step here is really to select from a mission perspective, do I want to code and have my code deployed automatically into my Openshift environment, pushed into GitHub, or do I just want to download it as a zip file and handle that myself? So in this case, I'm going to select to code locally and build it and deploy it into my local OpenShift environment. And then I'm going to press the down arrow and go to the next step. So the next step is really selecting the mission. What kind of application am I going to build, and what technology do I want to use for that application? So for example, if I want to build an application that uses a cache to improve the response time, I can do that. If I want to build a CRUD application, create, retrieve, update, delete, I can do that. Right? So here you pick the kind of application you want to build and go from there. So I'm going to do a CRUD application. Oops. Then I'm going to pick my runtime. I'm going to use Spring Boot, and I'm going to use the ROAR release versus community. Go to the next section. So at this point, the launcher is going to actually push the code to my Git repository, so it needs my credentials in order to do that. So I'm using GitHub here. So I've already entered my credentials, so we can just skip that step. And then the final step is really just defining the basics about the application from a Maven perspective. People aren't familiar with Maven. It's a build tool for Java. It essentially allows you to manage all of your dependencies quickly and easily for that application. So I'm just going to, instead of booster, I'll call this CRUD service. And then we'll go ahead and set up our application. So if I scroll back up, sorry, the large size here is making it a little convoluted. So what is it doing? So now the launcher is creating my GitHub repo. It pushed all that was too fast. It pushed all the code to it, and it actually deployed it into my Openshift environment. So if I go to GitHub, I can see all the code here, right? And I get a nice set of instructions if I want to deploy this manually into the Openshift environment. So it makes it easy for a developer to get up to speed quickly and easily with the application. The other cool thing, though, is if I go to my Openshift environment and log in, I can see it actually deployed my application, right? So this application, because it's a CRUD type application, requires a database. So it deployed the database. And it's now doing a build of my application, right? So that's the build down there that you can see. That's happening here. How many people here have seen Openshift before? A few, but not the entire audience. So if you're not familiar with Openshift, this view that I'm looking at is what I see in terms of a project and the application that's deployed in that project. The different components of the application are represented by these deployment configurations. So I got my database, like I said, and my Spring Boot application. So while it's building, let's go ahead and, it's just getting ready to push there. But let's go ahead and start editing the code. So I'm going to use an online IDE. Now, if you're a developer in the audience, you might be cringing a little bit. Online IDE, you're going to put my IDE in a browser, over my dead body, right? And that was probably my reaction when I first was looking at this about a year ago or so. But I used to think the same way about my word processor. I used to think the same way about my spreadsheet, my presentation software. And I've been running the Google Suite now and all that stuff in the cloud for ages. And it's been working great. So the IDE is no different. The great thing with this IDE, which is called Eclipse Che, by the way, is as a consultant, when I'd show up in an organization, one of the things that was always annoying was setting up your development environment. Take me a week or 2 weeks before I could get everything up and running and be in a position to actually be effective as a developer and make code changes. With Eclipse Che, what you can actually do is create stacks for your developers that mirror the requirements for your particular application. So when a developer wants in a development environment, they can simply spin a workspace up using that stack and be ready to go from within 5 minutes. So in this case, I already have a set of workspaces. So I'm going to select my workspace here, and we'll open it up. So when I start it up, I've got an empty slate. There's no application there, so we're going to go ahead and import it from GitHub. Then we'll give it a name, CRUD service. And we'll go ahead and import it. And it's a Maven project. All right, so now I've got my code imported. I can go ahead and browse it and start editing it as much as I want. There's my standard Spring REST controller. So you can see this is implementing an API. There's an API on /API/fruits that allows the front end to actually integrate with this application. The application's probably built by now. It is. So let's go have a look at it. You can see how OpenShift is managing all of this for me, right? I didn't create a DNS entry. I didn't create a load balancer, but I've got my route here that I can click on and access the application, right? And now I can go ahead and edit my fruit. I can add a new fruit like orange, and that goes into the database, right? So now that I've got my skeleton of the application, I can start making changes to it and improvements to it as a developer and go with it. So I'm not going to do anything major. Let's go ahead and though change the title. So I go ahead and change the title. So we'll change it in 2 spots. We'll change it in the HTML title up here. change it down here in the actual page, right there. I'll say one thing about Eclipse Che that took me some time to get used to is that it auto-saves. There's no save button. So it's like working in Google Docs, it's always saving, right? It's like, what are you doing? But that's really what source control is for, is to back that stuff out. But anyways, I made my change, so let's push it over to Git. So I'm gonna add it, then I gotta commit it. Standard Git processes, change title, commit. And then I'm gonna push it to GitHub. So my change is going through, it's got pushed to GitHub. And if I were to go to here and show you, you could see it. But the cool thing I want to show here is notice down here, I've got a new build going now, automatically, right? I checked in my code into GitHub, and it automatically kicks off the new build. So that, as a developer, I get that instance feedback in terms of making the code changes and being able to see what's happening. Now, right now, it's doing the simple build process, but you can certainly expand this capability out to encompass a full-blown pipeline if you wanted to, right? But it's all about getting the developer that rapid feedback in terms of their code and how it integrates with the rest of the team, right? And from a developer experience point of view, I can sit down and get up to speed with an application very quickly and easily using this kind of workflow, right? So let's see. It made the build. It's just pushing the layers. Take a few minutes for it to deploy the application. So the cool thing here that it's doing too is it's doing a rolling deployment because I only have one pod. There may be some downtime, but actually no, it looks like it's good. Openshift Automatic, remember we talked about KeyBank and how they're doing no downtime deployments? Openshift manages that for you automatically. If I had 3 pods in here and did a deployment, what I would see is that the old would go from 3 to 2 and new would go from 0 to 1, 2 to 1, 1 to 2, and so on, right? The application is always up the entire time, right? Now think about how much effort that is in a traditional environment in terms of managing that with 2 separate sets of infrastructure, load balancers, and a number of people that I used to have on call to do all that work, right? And now the platform's doing it for you automatically. So now my application is there. I can click on it again. And now you can see the new title up there, Fruit Editor, right, that I changed, and how fast that whole process was. So this next demo is a microservice environment written in OpenShift application runtimes. I have got 3 microservices. I have an orders microservice, a customers microservice, and an inventory microservice. And then I have a gateway that's fronting these microservices in terms of providing access to them. The orders microservices provides a very fine-grained API on orders, and we'll see that when we go through it. The gateway, on the other hand, is providing a much more full-featured orders API that enriches the content with additional information that come from the customers and the inventory. You'll notice the cool guy on the left with looking at the footprints. That's a tool called Jaeger. Anybody heard of Jaeger? Okay, so you got a couple people. It is not the giant robot from Pacific Rim, as my sales guy was trying to convince me. It is a transaction tracing tool that allows you to monitor how your transactions flow through the different services, and that's what we're going to see in this demo. So before I kick off this demo, I need to generate some, there's 2 things I want to show in this. I want to show Jaeger. The other thing I want to show is auto-scaling in OpenShift. Almost forgot about that. So here's those services running in my OpenShift environment. Let me make that a little bigger. So you can see everyone is right now running with 1 pod, right? If I click on the gateway, I've set up auto-scaling so that what auto-scaling is that the load on this application increases, it will automatically add new pods to deal with that new load. To set that up, what I've done is I've added resource limits. So you talked about self-service in an OpenShift environment. I'm fond of saying that, yes, we give people the capability to do self-service, but it's not the Wild West, right? It's not like developers can just deploy whatever they want willy-nilly and there's no controls in place. Operators remain in control with quotas and resource limits, which is what this thing is. What a resource limit is it's saying how much CPU or memory your application is going to use, and OpenShift uses that in a variety of different ways. So in this case, I said my application requires 400 millicores at a base level. A millicore is simply 1/1000th of a core, right? So in this case, I'm saying I want 40% of a core as kind of my base guarantee, and allow the application to scale up to 60% of that core. If I go back here, and then for the autoscaler, I've configured it so that I've got a minimum of 1 pod, maximum of 5 pods is allowed by the autoscaler. And what I'm saying is that whenever I reach 60% of that 400 millicore limit, start adding new pods to the application. So let's kick off my load. I've got a load generator running in Amazon. Make that a little bigger so you can see what's going on. So this is simply using a tool called Postman to run my load. There's a command line version of it called Nunn. So I'm going to run 15 processes in parallel to generate that load. And we'll continue on with the demo. So now my load is being generated, and it'll take a little bit of time before these things start kicking in. So we're going to look at the next thing in line, which is the gateway and the orders. So remember I said the order is a very basic order. This is what's coming from the order service, right? You see the customer UID. You see a product UID, but no other information about the customer or the product, right? If I want to see an enriched view, though, this is what the gateway is providing. So you can see here a much more detailed view of that same order, in that I'm getting all the information about the product in terms of its description, its name, etc., as well as the customer information. The guy who wrote this demo was a big fan of a game called Monkey Island, which is why you see things, idle of many hands, the rubber chicken with a pulley in the middle. It's a kind of a comedy game. All right, so if you go back to Openshift, has anything started kicking off yet? Not quite yet. Give it a few more minutes. But let's go take a look at our transaction tracing. So when you get into a microservices environment, one of the things that often comes up is, okay, how do I monitor this? How do I understand the flow of transactions through my microservice mesh? Because it's not a case that your front end or your consuming application calls one microservice, that microservice returns a response, it's done. That microservice in turn may call other microservices, right? It may aggregate and compose a response that's similar to what the gateway is doing here in order to provide a response. So what Jaeger does is it allows you to, why is that coming up? Oh, sorry, there we go. What it allows you to do is view all of the traces that are happening. Where are my traces? Come on. Okay, this is weird. Okay, now this is how you know the demo is real, is when things don't work as you expect it to work. So in this case, I can click on the health transaction, and I can see bars in terms of where the different work is going. But it's a little more illustrative when I get my proper transactions going. And for some, oh, there we go. There's one there. Perfect. So in this case, this is a hit against the gateway, right, where it's composing and enriching all of those requests. So you can see initially comes to the gateway here, and I can see it's got a status code of 200. And it's coming in on the get, and then it starts going through the gateway itself before it gets to the order. So once the gateway, you're saying I want order 1, so it's got to go through and call the order service to get that. Once it gets through the order service, then it calls the customer service to get the customer information, right? And then finally, it goes through the inventory for every product in that in that order in order to get its information as well. But the cool thing here is that all of these bars represent the duration that is being spent on these different operations, right? So as an operator, as a developer, and I'm trying to understand the performance characteristics of my application, one of the key points is understanding what is it actually doing in terms of the different systems that it's interacting with. And that's what Jaeger provides for you, for your application, allow you to do that transactions, those tracings. So let's see if it's started scaling up here yet. It's going to be stubborn and probably not do it for me for some reason. I don't seem to be generating the load that I did before. Try one more time here.
For Jaeger to work, do you need to put some hooks, or how does he know what to monitor?
Yeah, so in your code, you essentially have to put hooks that tell Jaeger what it's monitoring. But the cool thing with Jaeger is that once you start going to Istio, the envoy will start doing those hooks for you, right? And managing those aspects for you more at the network level. So
Beginning methods and the methods.
yeah. So when microservice A calls microservice B, it goes through that envoy proxy, and that envoy proxy will integrate with Jaeger in terms of providing information about those flows as it goes from layer to layer. So you still need to provide some information, but it doesn't necessarily need to be as detailed as it is when you do it in the code right now when you're just using it manually. Yeah. Oh, there we go, finally. It's scaling. So now you can see I'm going from one replica to two replicas, right, on all my applications as the load's coming in and driving it up through that. So I have a lot of customers that struggle with dealing with periodic load, right? So some of my telco customers, for example, whenever Apple launches a new iPhone, get an enormous amount of load that happens. Similarly, whenever there's an offer at a retailer, for example, special offer, they get a lot of load too, right? And they need to be able to scale their infrastructure very quickly and easily in order to respond to that. This feature allows you to do that and be able to scale your application quickly and easily. When you think about what would it take for an operator to do this in a traditional environment, right? I don't have to phone up Bob in the virtual machine team and say, spin me up a new VM. I don't have to phone the networking team and say, you know what, add a new entry to the load balancing farm to make that happen. This can all happen within the platform. And then once the load is finished, it automatically downscales it again. So we saw how I kicked off the build automatically when I made a change in GitHub, right? And that just clicked off the simple build. But let's say, for example, I want to do something a little more complicated. I've got a project that's got a development environment, a test environment. So what this example is really showing you is all of the different ways in Openshift that it's easy to manage your development environment. So I've got an application called Product Catalog. It's got a development environment here that I can click on. Right, and you can see it's a simple product catalog. And it's also got a test environment that is the same thing. Up here, though, I've got a project called CI/CD that's providing continuous integration and continuous deployment. So this is managing the building of the application. It's moving through the different environments, right? So if I go into GitHub, get rid of this stuff. So if you remember that page that I showed, there was no branding on it. And usually the scenario I walk through is I'm Tom, a developer, and Tom's being asked to add some branding with the marketing folks. So he's going to go in and make that change. I'll just do it in GitHub here directly. Now, if I was a really good developer, I would write all this code out, but I'm not, so I just have it ready for me to uncomment and deploy, and I'm going to make that change and commit it. Now you can see my pipeline starting off again, right? And this is actually going to build my application and go through the different environments. So if we look at the steps that it's going through, it's building it in development, then it's going to deploy it in the development environment. It's going to run an automated test on it, a simple smoke test. And then there's going to be a manual step where I approve its deployment to the next phase. And then finally to get deployed into testing, right? So this pipeline is what gives you that control that you're asking about in terms of how the application gets moved between the different environments and deployed. So it should almost be ready for the next step. Might take a few seconds. So we go look at the deployment, the deployment in development. You can see here it's going to be doing the rolling deployment where the application's always up, right? So as the old one comes down, the new one comes up, right? So Openshift is managing this all for you automatically, and it doesn't require intervention by the operations team or developers in order to be able to do this. So now it's up in development. It'll ask me for the next step. And we'll say yes, proceed. Now we're deploying and testing, and same idea. Right? If I go to the testing environment, here I've got 3 replicas, and I'm doing the same rolling deployment that I did before, right? Application's always up, always available. When I was doing this manually at a telco company back in 2011, 2012, I would have literally killed people for this capability if it would have saved me, doing those all-nighter deployment sessions, because they were extremely painful. This is what lets you do things like I was talking about, being able to do production deployments during working hours, right? Nobody likes to work nights. Nobody likes to work on weekends to do that stuff. Why should we? We don't need to do that anymore with this type of technology. All right, so now it's deployed and testing. If I think I have to use an incognito window. If I open it up again, you can see that change I made is right up here, right, where I've added the logo. Nobody said Tom was an artist, though. Unfortunately, it's a pretty lousy logo, but so that shows the process of moving an application from development to test. And similarly, the same process would happen to production, right? I could add a new production environment, tack onto the pipeline, and go from there. How many people here use Jenkins? A few? Okay, so all of this is powered with Jenkins, integrated within the Openshift environment. If we go back here, you can see in the tools project, I'm running a Jenkins pod down here that's managing that pipeline. If you're not familiar with Jenkins, it's a very common tool in the Java world for doing continuous integration and continuous deployment, or continuous delivery. All right, I think that's good for me. I'm finishing 5 minutes early, so you get to have lunch earlier, so that's good. Thanks very much for your time today. I appreciate it. I hope you enjoyed the talk, and enjoy the rest of the day. Thank you.